Welcome. I'm pleased to continue the session by discussing carbohydrate quality, relevant metrics, and implications for consumers and policymakers. My disclosures are listed here. It's really clear that carbohydrates play a major role in metabolic health: obesity, weight loss, weight gain, type 2 diabetes, the microbiome. And yet there's also tremendous confusion about what a healthy carbohydrate, or if even indeed there could be a healthy carbohydrate. Consumers are faced with a range of different kinds of breads, cereals, cooked cereals, crackers, energy bars, and it's very, very difficult to differentiate, are all of these foods that should be avoided, or all of these foods that could be healthy? And there's really scientific confusion and controversy over this issue as well. It's clear overall that reducing carbohydrate and replacing it with healthy fats and proteins is good for metabolic health. This is one example of a trial testing 3 different diets over 2 years. And like many, many trials, higher fat diets, low carbohydrate, high fat diets perform at least similar, if not better, than low fat diets for weight loss. This is an uncontrolled interventional trial, or open label interventional trial. I should say not randomized. 260 diabetics were put on very, very low carb diets. And it's a busy slide, but it's really just intended to show that we know in patients with diabetes, if they're put on low carb diets, dramatic improvements are seen in multiple metrics. These are cholesterol levels, hemoglobin A1C, weight, and also this shows changes in medications. Many medications can be eliminated. Blue is elimination or decrease in medications when diabetics are put on low carbohydrate diets. And yet all carbohydrates are not the same. This is a meta-analysis of prospective observational studies looking at risk of incident diabetes. And for whole grains, for increasing intake of whole grains up to about 2 servings per day, there's lower observed risk of incident diabetes. And yet for refined grains, for increased intakes, there's higher risk of incident diabetes. And so, this suggests that not all carbohydrates are the same. And many other meta-analyses suggest this. This is a summary of meta-analyses. Each line on this graph is a different meta-analysis. Total carbohydrate, looking at coronary heart disease, stroke, or diabetes, is actually not strongly related to risk. There's trends, non-significant trends, borderline trends towards higher risk with higher carbohydrate intake. But when you look at different aspects of carbohydrate quality rather than total quantity, for example, glycemic index, strongly linked to incident diabetes, glycemic load, significantly linked to both heart disease and stroke, as well as diabetes. Total dietary fiber linked to lower risk of heart disease and diabetes, and cereal fiber specifically also linked to lower risk of heart disease and diabetes. It's clear that quality is more important than quantity. And so how do we define carbohydrate quality? Is there a simple and practical definition for industry, consumers, and policymakers to all try to improve carbohydrate quality in the world? Unfortunately, there's not one simple definition. There's many different metrics that can be shifted independently. So there's whole grain content, fiber content, glycemic responses, and food structure. Whole grain content, for example, just means that you've put different components of the whole grain into the product. You have the endosperm, which is the starch, the bran, which has the fiber and many vitamins and minerals, and the germ, which has additional minerals and fatty acids. And so putting the whole grain into a food, or even separating those components, bran, germ, and endosperm, and reusing them, something can be a whole grain. Fiber content really refers to just having sufficient bran, and not even actually all of the bran, because it could even just be the fiber stripped of the minerals and phytochemicals. Glycemic response is not exactly the same as either fiber or whole grain content. One example is comparing a refined cereal like Cheerios, which is whole grain but highly processed, versus steel cut oats. They have different glycemic indices. Even though Cheerios has whole grain and has fiber, it's more rapidly digestible than steel cut oats. And then lastly, food structure. Beverages, for example, versus solid foods seem to have very different effects on metabolic risk. And in the United States and in many countries, this is a major issue. A recent analysis we published shows that over half of all calories come from carbohydrates, and most of that is what would be considered low-quality carbohydrates: refined grains, potatoes, other starchy vegetables, added sugars, juices, and other carbs. Only 9% is from higher quality carbs, whole grains, fruits, beans, and non-starchy vegetables. And here are the trends over about 16 years in the United States, and you can see that slowly consumers are consuming less low-quality carbohydrates and more high-quality carbohydrates, but this change is very slow. And there's considerable consumer confusion and uncertainty. There's so many different types of bread, cereals, packaged snacks, crackers, energy bars, bakery products, all of which can have mixed amounts of whole grains, refined grains, sugars, natural sugars, fiber, and other corresponding nutrients. So how can we have a practical metric that's useful for the public, for policymakers, and for industry to try to target and create healthier whole grains? Well, a paper published by my wife at Harvard several years ago started to look at this question, and that analysis looked at three different possible definitions. One is using the industry-sponsored whole grain stamp, which is common in the United States, where industry pays the Whole Grain Council to be able to put this stamp on their product. Two is using USDA definitions, and there are actually three different USDA definitions, all differing variations of using the ingredients list. So the consumer needs to go and look for specific things that are in the ingredients list. And last was a very simple and practical ratio of total carbohydrate to fiber, which was proposed by the American Heart Association. And the theory behind this ratio is that total carbohydrate, which is both starch and sugar, and fiber, which is at least a metric of bran and whole grains, gives you kind of an overall carbohydrate balance. And so, for example, here, a serving has 24 grams of carbohydrate and 1 gram of fiber. The ratio is 24 to 1, the ratio of carbohydrate to fiber. And what this analysis found, looking at nutritional, looking at grain-rich and carb-rich products in the United States, that looking at a range of different aspects of nutritional quality, among these definitions, by far the best was using the simple ratio of total carb to fiber. If some product had a ratio greater than 10 to 1, like this one, 24 to 1, it should be avoided. Less than 10 to 1 was a good choice with many options in the food supply. And less than 5 to 1 had the best nutritional quality, but had fewer options. Fewer products met the 5 to 1 ratio. And you can operationalize this by looking at some brand name products here. This product, for example, has 24 grams of carb and 1 gram of fiber, only 24 to 1. This cereal, in contrast, has 42 grams of carbohydrate and 12 grams of fiber, so a ratio of about 3.5 to 1. And even this cookie has a ratio of 5 to 1, 20 grams carb, 4 fiber. So based on this definition, this cookie is actually a healthier choice than the cereal. And you'd think that's funny, but actually if you look at the ingredients list and you look at what's in here versus this product, which is milled corn. Milled corn is essentially all endosperm. So this product is essentially glucose. And this product actually has many, many whole grains and actually some other healthy products. And so this, you can see how the ratio can be operationalized and used. This has been now looked at in other studies. This is a study from Brazil looking at the 10 to 1 carb to fiber ratio and looking at foods consumed in a cohort study in Brazil. Products that meet the ratio, less than 10 to 1, at least 1 gram of fiber for every 10 grams of carbs, and products that don't meet the ratio in red. And this is the content per 50 gram of a range of nutrients, and all of them were significantly different, where products that met the ratio had significantly higher fiber, significantly lower total sugar and added sugar, significantly more protein, more iron, more selenium, more magnesium, and more zinc. And so showing that in Brazil, as in the United States, this simple ratio predicts healthier food products. Also in this study, observationally in this cohort study, the investigators looked at the replacement of foods that met the ratio versus those that don't, and how they related to cardiometabolic risk factors. And so in this multivariable adjusted cross-sectional analysis, for every percentage of energy of grain foods that met the ratio, replacing foods that did not, there was borderline but not quite significant higher HDL, but significantly lower triglycerides, significantly better triglyceride to HDL ratio, lower insulin levels, and less insulin resistance, and not significant differences in blood pressure or weight or total cholesterol or LDL cholesterol. And so these particular risk factors that were linked to improved carbohydrate quality, atherogenic dyslipidemia, insulin resistance, and insulin, are exactly the ones that we would predict would be most strongly influenced by healthier carbohydrates. Now, what about the additional role of sugar? It's clear that the 10-to-1 carb to fiber ratio is a simple but pragmatic metric which identifies healthier products. As I mentioned, this puts together in all of carbohydrates starch and sugar and doesn't really differentiate whether a product has starch or sugar. Is further differentiation of starch versus sugar helpful? So in a recent analysis, which is now in press in PLOS One, we looked at this question by testing 3 additional ratios compared to the original 10-to-1 ratio. The first iteration was to check a limit on free sugar so that there can be no more than 1 gram of free sugar for every 10 grams of carb. And this is based on that 50% of energy comes from carbs, and so from that 50%, there should be at most 5% energy from free sugars. The second ratio, a little bit more permissive, 10-to-1 to 2, allowed up to 2 grams of free sugar for every 10 grams of carb. And this is a more permissive assumption that maybe all of your 10% energy from free sugars would come from carb-containing products. And then the last one, which I think is actually maybe the most interesting, is to see that there's a limit on sugar, but depending on the amount of fiber or whole grain in the product. If you have more fiber, you have more whole grain, then a little bit more sugar is permissive. And so here, it's the 10-to-1 carb to fiber ratio and no more than 2 grams of free sugar for every 1 gram of fiber. This ratio is the 10-to-1 to 1 to 2 ratio in shorthand. And again, this is based on 30 grams per day of fiber and less than 10% energy from free sugar, or 60 grams per day. So we looked at how these 3 ratios compared to the original ratio looking at food products in the United States. This is based on NHANES, and what's important here is this is foods as actually consumed by Americans. Over 2,000 carb-rich products were evaluated. And so this is showing the percent meeting each metric. And so first, just looking at the 10-to-1 ratio alone, what's interesting is that across these different food categories, there's very different percentages of products meet the metric. So among sweet bakery products, only 3% do. 97% of products don't. Among breads, about 1/3. Among cold and cooked cereals, about 40%. Among cooked grains and crackers, about 1/3. Quick breads and baby cereals, less than 10%. So first, there's a wide range of meeting this ratio among different food products, and overall, it's about 1 in 4. That's the first interesting thing. The second interesting thing is, well, what happens when you add these additional sugar restrictions? And so first, the most important large category that influences cold cereals. Cold cereals with the most restrictive sugar restriction goes from 4% to only 9%. With the next most restrictive, it still goes to 21%. And interestingly, if you allow sugar in products that have a lot of fiber, which is a lot of bran or a lot of whole grains, then the restriction is not as severe. Looking at breads and cooked cereals and crackers, you see a similar pattern, but less difference. And so there's a significant reduction in the percentage meeting the criterion with the most restrictive free sugar restriction. But with a 10-to-1 to 1 to 2, it's almost the same. And then lastly, there's some less common products, but these products like snack and meal bars and smoothies and grain drinks, these are products that may have whole grains, but also have quite a bit of sugar, and they basically completely get eliminated with some of these sugar restrictions. So how do these different indices compare in terms of nutritional quality? What this chart shows is products in the United States that are consumed based on NHANES that meet or do not meet each of these ratios, and the difference in calories, fat, saturated fat, protein, sugar, added sugar, and free sugars for each of these ratios for products that do and do not meet the metric. And what we see is that all of them work well to identify products that are more nutritionally sound. All of them identify products with lower calories. All of them identify products with less fat and saturated fat, although I would say that less fat by itself is not a sign of healthfulness. All of them identify products with more protein, with less total sugar and added sugar, and less free sugar. Now, looking across the ratios, the calorie differences and the sugar differences are larger for these most restrictive sugar metrics, which makes sense because, again, they're restricting sugar. And in contrast, the protein differences and some of the other differences I'll just show you are larger for the other metrics. So here are some additional important nutrients: fiber, sodium, potassium, magnesium, folic acid, thiamine, riboflavin, and so forth. Here again, most of the metrics identify healthier products, but fiber, sodium, potassium, magnesium differences are largest with the 10-to-1 and the 10-to-1 to 1-to-2. And in fact, these two metrics that are most restricted on sugars actually identify significantly lower thiamine, riboflavin, niacin, and vitamin B6. And so in summary, all four metrics identified products with lower calories, fat, saturated fat, and sugars. All four identified products with higher fiber, protein, potassium, and magnesium. Comparing these metrics, the ones that were most restrictive on sugar identified larger differences in calories and sugar, but smaller differences in fiber, protein, potassium, and magnesium. And in fact, the 10-to-1-to-2 and 10-to-1-to-1 also identified lower folic acid, thiamine, riboflavin, and niacin compared to products that didn't meet these criteria. Interestingly, the 10-to-1 and 10-to-1 and 1-to-2 also identified higher B6, vitamin E, zinc, and iron, all very important nutrients. Three of these ratios also identified lower sodium, and the 10-to-1 was the only one that identified higher vitamin B12. And so if you look at this overall identification of products, the 10-to-1 and 10-to-1 and 1-to-2 overall identify the largest range of more optimal nutrients, but smaller differences in calories and sugars compared to the more restrictive sugar metrics. And so in conclusion, it's clear that carbohydrate quality is highly relevant for metabolic health, but there has been no well-defined metric for consumer choices or policy targets. Among various recommended approaches, an ingredients list, a whole grain snack, or others, a simple ratio of carb to fiber performs best. Additional ratios that further limit sugar, all of these ratios work to identify products with generally higher nutritional quality. The 10-to-1-to-1 and 10-to-1-to-2, the most restrictive sugar metrics, identify the fewest product options, the smaller benefits for protein, fiber, potassium, and magnesium, and actually lower levels compared to products that don't meet these of folic acid, thiamine, riboflavin, and niacin. And in additional analyses, this was largely due to exclusion of fortified cereals. And so overall, I believe that the 10-to-1 and 10-to-1, 1-to-2 ratios identify the largest overall nutritional improvements and the broadest product options. And these results really support the need to test these ratios now for consumer messaging or policy actions. They could be used, for example, as part of front-of-pack logos, nutrition facts panels, and or industry targets. And thank you very much for your attention, and I look forward to the panel and discussion.